Welcome to the KonyOne 5.0 video tutorial series. In this edition, we'll look at how to create a composite service app. We'll start with the composite service app that is there for download in the developer.konya.com/platform apps. We'll download the archive from this location into the workspace and use that as base for our project. Once the archive has been downloaded, you can select the archive file from the navigator and import the project onto the workspace. So we see we have a 5.0 app here. And so basically the concept of a composite service is that you can use the services that are defined otherwise in your service definition and call multiple services at a time. So in this case, we have two services called Google Feeds, which is an RSS feed for getting news from Google. The individual response for that you can test from here. It is giving you the RSS feed for Google News, and we have a similar RSS feed for Yahoo News. So both these are XML services which are by itself going to give you data only for that service. So using the concept of a composite service which Kony offers, you have the ability to club multiple services and call them sequentially or concurrently from a single service. So the way to go about defining a composite service is to select Create from the Composite Service menu and choose the services that are there and choose whether you want to call them sequentially or concurrently. In this example, we are just taking the news feeds from Google and Yahoo and showing them at a time in the app. And since there is no dependency between these two news feeds, we are calling them concurrently so that the time of execution is the least. So this way, what happens is the multiple calls are made by the middleware to the backend, but the device makes only a single call to the Kony middleware. That way, the long pole in any data transfer or service call is from the device to the middleware, because that is over 3G or Wi-Fi or whatever. It's not going to be as fast as a service call being made from middleware to any backend. So by using this composite service model, you save a lot of time so that you can make multiple service calls from a single service call from the device to multiple backends and get the job done. So we just walk you through this application and show you how this multiple services information is shown in the app. So to start off with, we need to go and change the properties so as to point to a valid server. In this case, I'm going to add my system IP address and port. I'm having a KMap running at that port in my system. So I have the service definitions. I've created the service definitions. And then I publish the same. I've already defined the properties in my Properties tab of the project, so I could just go ahead and publish this into my server. So now that the services have been published to the server, I could build an application and hit that server and get data back from the scene. Seen how to import and see what a composite service is. Remember, this was downloaded from the 4.1 section of the app. So let us start with upgrading the application, the current version of the Kony software, which is Kony version 5.2. So it says successfully upgraded. The time taken for the same is 514 milliseconds, which is like half a second. And now we want to change the development language from, say, Lua to JavaScript. So we go about with selecting the change development language, and it gives you a warning saying yes, it will run the Lua to JS tool and will change the language to JavaScript. So we go ahead and press yes, and the language has been changed and it has successfully upgraded the app to a JS version of 5.2 in 687 milliseconds. So now we could go ahead and try to build the application. A few things to see before we go ahead with the application build is see what the ID of the application is, because this is what will be the XML. This is the name with which the application will be recognized in the device once it's launched. The server, which I've already modified to point to my local system. And in case of I'm building for Android, so I need to see what is the minimum version that it is being set. So it is pointing to 2.1, which is the version which is, so I'm trying to run it on 2.3. So I'm changing the SDK version to point to the version that I have in my system. So just because I'm building only for Android, that's the only setting that I need to change. And I could change the build to release and go ahead with building the same. So I go and build the app now for Android. So once the app has been built for Android, you can run the emulator by clicking on the emulator's panel in the IDE, and that launches the Android emulator. Once the app has been installed on the Android emulator, you could look at the same. So this is the landing page of the Composite Services sample app. We'll also start the ADB logcat, which is the debug logs for Android as is, which will help us look at some information if anything goes wrong in the sample app, or to just look at any print statements that you might have had. So this says that it's showing the Composite service and going to get data for Yahoo News and Google News. So I'd also like to go and point to that, if you have the KMap server, KonyOne server installed in your system, you'll be able to look at the logs in the middleware.log file. So I'll go and clear up the logs before running the service. So I'm clicking continue. It says click below to start the Composite service. And it gets data from the Yahoo News service and Google News service and shows both of them here. And we know that we had chosen the concurrent mode, so both the service calls were made at a time without waiting for either of them to return. So we see that it's pointing to the Yahoo and Google, and we can view more records of the data by clicking on the More button at the end of the tab, and that loads a screen with more news. So we can see more items of the Yahoo News in this selection. Now that we have seen how a concurrent composite service works, we could go ahead and add services for creating and viewing at sequential services. So we'll start with adding a get-lat-long service, which is a Google service which is going to return GPS coordinates of a location based on an address. So I'm entering the address text as an input parameter, and I've entered the Kony address, and it returns back a response, which I've tested from the IDE. And I go ahead and define the output parameters that I need to take out from the scene. So I'm taking out the address that is returned there, and the latitude and longitude coordinates returned from the scene. Now that I've defined the lat long, I'm going to add a service to get weather for this specific latitude and longitude. I'm using a underground service for the same, and I'm entering the lat long that I got as output from the previous service to this. At this point, I'm just checking them out as individual services, but this is the exact way in which it will work in the composite service too. In the composite sequential service, the output of one service is the input to the next. So if the first service is returning, say, the latitude and longitude, it will be used as the input for the subsequent service. Now that we have tested out the individual services of the lat long and the weather forecast, we'll go ahead and create another composite service and call these two services sequentially, one after the other. First with the lat long, which returns the latitude for an address, and then the weather forecast, which returns the weather for that particular location coordinates. So we generate the service definition after modifying and adding the composite service, and we'll go ahead and publish the service to the server for the server to have, for the changes to have effect. Since the coordinates have already been defined, server IP input, the publishing happens as is. It doesn't prompt for the password again. We'll go ahead and create a new form called FRM weather, where we'll define the UI elements required for showcasing the address and lat long and the weather information that we have got from the previous service as is. We have a get weather log, which is going to be used to call the composite weather location service. Here we are passing the text field address that the user has entered as an input parameter for the service, and then after the service returns, we have added mappings to map the data back from the composite service to the UI elements in the screen. So we just need to click the output from the service and the corresponding value of the variable that you want to fix it. In this case, the string property of the text property of the corresponding labels and so on. So once we have defined these mappings, we could go ahead and build this application, say for Android, and we can see our sequential composite service in effect. So once the app has loaded, I've changed the start form to the weather screen that I've defined now. I go ahead and enter the zip code, in this case, of the address that I'm trying to find out. So I enter the zip code and select the Get Weather Unlock button, and it returns data from both the services. You can see the address and coordinates on the left from the first service, which was an input to the second service, and the second service has returned weather information, wind, humidity, and stuff. Now we look at the middleware log here, which shows us how the output of one service is being made as input of the next service. So we can see that the service calls are made to both the URLs, the Google and Wonderground over there, and the output of the first service has come back, which is having the coordinates, and the output of this, you can see here the JSON string, which has the address and the lat long that is fed as input to the subsequent service in the input map, and the service call to the Wonderground is made with the same. So we can try this out with modifying the address to a different zip code, and you can see the results. So in this session, we have seen how a composite service works and how we can use it to make multiple concurrent or sequential calls to single or different backends, so that the response from the device is much faster than what would have been if those calls were made individually one after the other. Thanks for your time.